I brought a computation that embarrasses people because it looks too small to contain a serious mistake. 3 binary 64 numbers, A equals 1016, B equals negative 1016, C equals 1. Evaluated as A.B.C, the printed answer is 1. Evaluated as A.B.C, the printed answer is 0. Same input, same nominal operation, same machine format, 2 answers. I trust the first printed answer only because I know the exact real sum and because the first evaluation happens not to discard the unit. That is already an important confession. The trust came from analysis outside the program. Repetition did not earn it. 1 billion identical zeros from the second order would remain a reproducible mistake. I propose that we resist beginning with machinery. Before rounding modes, compilers, or underflow, write the mathematical object, write the implemented object, and admit where they cease to be the same object.
Anthropic, I like the example, but it is almost too favorable because you know the ground truth. In most consequential computations, the reason we run the program is that we do not know the answer. My contribution is an internal rate of return calculation for a cash flow series with alternating signs. The spreadsheet prints 18.4%. Anthropic, the investment committee, trusts it because 3 people opened the same file and saw 18.4%. But the polynomial can have multiple real roots, and the solver's initial guess can select which one becomes the official return. Change the evaluation order inside the polynomial, or merely change the starting point, and the answer can jump basins. Anthropic, there may not even be a uniquely intended scalar called the IR. So my question is adversarial. Are we bounding arithmetic error around a well-posed answer, or manufacturing mathematical respectability around a metric whose definition has already failed?
Those are not separate pathologies. William shows a smooth mathematical operation acquiring a jagged computational coastline. David shows a business name placed over a landscape with several attractors, after which the chosen attractor is mistaken for the landscape. My computation is the estimated tail exponent of a synthetic Pareto sample. The script prints 1.73. I trust neither the last digit nor, without further inspection, the premise that one exponent adequately describes the tail. Yet I do trust a more modest answer. Over a specified threshold interval, under a specified estimator, the estimate remains between 1.66 and 1.82 when the accumulation order, precision, and the threshold are varied within declared limits. That interval is less impressive than 1.73 and more informative. Perhaps our smallest error bound must sometimes enclose not merely rounding error, but the instability of the question under nearby legitimate formulations.
Rapidly. I brought something brutally operational, a constant product market quote. Reserves X and Y, input delta X, phi factor F, output computed as Y minus K, divided by X plus F delta X with integer token units and a final floor. The program prints 24,917 units out. I trust it because the chain will execute exactly those integer semantics rapidly. But that answer can be economically wrong while computationally exact. If an off-chain simulator evaluates in floating point, rounds to nearest, and prints 24,918, it may set a minimum output condition that makes the real transaction revert. If both simulator and chain print 24,917, they can still share a mistake in fee placement rapidly. Here, reproducibility has at least 3 meanings: same source on different CPUs, same semantics in different implementations, and same state transition under consensus. I care most about the last, but consensus can canonize an error. How do we express a bound that distinguishes stable arithmetic from stable agreement?
Mine is a softmax probability from a classifier, logits in one implementation, with XP computed after subtracting the maximum. It prints approximately in float 32 depending on library details. Turn on flush to 0 and some of those become 0. Change reduction order in a much larger vocabulary and the normalization shifts. Yet the top class remains class 0 with an enormous margin. I trust the decision more than the printed probability vector. That distinction matters because many systems expose the probability as if it were the product, while the downstream behavior may depend only on argmax or may sample, in which case the tiny tail is behavior. We need to bind an observable, not simply every intermediate. The smallest useful bound may be a certificate that the decision is invariant, even when the low-order numeric story is not.
Good. We already have 4 different targets hiding under the word answer: an exact scalar, a root selected by convention, a statistical estimate under model uncertainty, and a discrete decision induced by approximate numbers. Kyle adds a state transition with legislated arithmetic. Let us put a rule on the board. An error bound has the form distance between computed output and intended mathematical output less than or equal to b. But every noun there must be named. Which distance, which computed output, which intention, which input set. For my 3-term sum, the exact result is 1. The second parenthesization has absolute error 1 and relative error 1. A usual forward error estimate based on machine epsilon and the sum of magnitudes is enormous, around several units, and therefore cannot certify the digit. That pessimism is not a defect. It tells us the problem, as naively evaluated, is ill-conditioned with respect to that execution path.
Anthropic, I want to press on intended. In an organization, intention is frequently reconstructed after the result is seen. If the spreadsheet prints 18.4 and the hurdle rate is 15, everyone discovers that the intended route was the one near 18.4. If another implementation prints -6, suddenly the convention becomes debatable. Anthropic, a bound prepared after the answer can be a narrative defense rather than a constraint. So I would add a governance condition: declare the acceptable output set before running the perturbations. For the IR example, perhaps the correct output is not x plus or minus epsilon. It is the set of all roots in a declared interval, accompanied by a warning when cardinality is not 1. Anthropic, stability then means the root set is isolated under coefficient intervals induced by arithmetic and input uncertainty. If the set changes topology, no tight scalar error bar should be permitted.
Yes. A single error bar often performs an act of false smoothing. Imagine a coastline measured with rulers of length 1 kilometer, 100 meters, 10 meters. The length does not converge in the innocent way the surveyor expects, because the object and the measuring scale interact. In a tail estimate, changing the threshold is not a nuisance perturbation equivalent to changing rounding. It reveals structure. We should not pour all variation into one undifferentiated plus or minus. Let us separate at least 3 envelopes: arithmetic error with the mathematical formulation frozen, algorithmic variation among implementation claiming to solve that formulation, and specification variation among nearby questions we are genuinely willing to call the same question. A result can be arithmetically stable, algorithmically fragile, and specification dependent. Calling the largest envelope error conceals where responsibility lies.
Rapidly. That separation is useful, but I want a test someone can run, not only a taxonomy. Suppose I have 2 implementations of the quote. One uses exact integers matching the contract. One uses float 64. Rapidly. We choose adversarial reserve sizes near the integer precision boundary, evaluate the float version under round to nearest, upward, downward, and towards 0, then reorder the algebra, yk.x dot versus yd.x dot with fees placed explicitly. We compare each result after the protocol's floor, rapidly. The smallest operational certificate is not that the floating value differs by less than half a unit. It is that every permitted evaluation maps to the same integer output. If the interval straddles an integer boundary, we have no decision stability, even if the interval is microscopically narrow in relative terms. The discontinuity belongs in the bound.
That is exactly the classifier case. A norm bound on logits is useful only through the decision boundary. If the top 2 logits have margin m and each logit error is bounded by e, argmax is stable when m is greater than 2e. We do not need every probability accurate. But if we sample, the relevant distance changes. Total variation between categorical distributions, perhaps with an explicit accounting of mass flush to 0. The same tensor can be stable for greedy decoding and unstable for rare event sampling. In machine learning, we often report deterministic benchmark scores, while the implementation contains non-deterministic reductions, fused kernels, stochastic sampling, and data order effects. Then we fix a seed and feel scientific. A seed can freeze one path through an unstable procedure. It buys replay, not trust.
Let us perform the first perturbation on my sum. Under round to nearest, ABC gives 1 because AB is exactly 0. In ABBCC, BCC rounds back to B because 1 is below half an ULP at that magnitude. Then AB is 0. Under rounding toward positive infinity, BCC becomes a representable number slightly less negative than B, so adding A produces a positive spacing-sized residue, not 1. Under rounding toward negative infinity, BCC may remain B, and the result stays 0. The variation is not random noise around the truth. Directed rounding exposes the enclosure. If we evaluate an expression once downward and once upward using interval arithmetic, respecting dependencies, we may enclose the exact result. But naive intervals can be absurdly wide. Still, an absurd bound is an honest refusal to certify.
Anthropic, and there is a political temptation to call the absurd bound a tooling failure. The executive wants one number. The engineer produces an interval wide enough to cross the decision threshold. The interval is then described as too conservative, and someone selects the central sim estimate because it is actionable. Actionability becomes a euphemism for deleting uncertainty. Anthropic, I am not arguing against decisions. Decisions must occur. I am arguing that the decision rule should consume the interval openly. If every plausible IRR crosses the hurdle rate, proceed. If none does, decline. If the set straddles it or includes multiple routes on different sides, escalate to a different economic model. Anthropic, the computation should be allowed to return this metric, cannot decide without being treated as defective.
There is also the reverse temptation. Uncertainty can become ornamental sophistication, a way to avoid being wrong by refusing to be definite. A wide interval is honest only if we can explain its sources and shrink the relevant ones. For my tail exponent, I can accumulate log ratios with compensated summation, compare pairwise and sequential reductions, recompute in higher precision, and place an arithmetic envelope around the estimator. That envelope may be tiny. Then I vary the threshold and discover a much wider structural envelope. This tells me not merely that I am uncertain, but where investigation has leverage. More precision will not cure threshold dependence. More data might, or a model that admits changing scale. A useful bound should direct the next act.
Rapidly. Let me challenge the higher precision instinct too. People say, we reran in 256-bit, so that is ground truth. But if the formula is wrong, precision hardens the wrong answer. If the reference implementation shares code with the production implementation, agreement is weak evidence. Rapidly. If they share the same rearrangement, same unit conversion, or same sign convention, they can agree perfectly. I want independence in the validation path. For the market quote, derive the integer inequality from the invariant, implement it separately, and use exact rational arithmetic for the oracle on bounded test cases rapidly. Then fuzz around discontinuities, reserve limits, one-unit inputs, fee transitions, overflow edges. The certificate includes provenance, different derivation, different representation, and test points selected to attack boundaries rather than flatter the common case.
In neural systems, the analogous oracle often does not exist, but metamorphic relations do. Adding the same constant to every logit should not change softmax. Permuting classes should permute probabilities. Splitting a reduction into chunks should not substantially alter a declared observable. Computing logmax directly should agree with log of softmax where the latter is representable, but the direct form should remain finite farther into the tails. These are relations, not known answers. When they fail under evaluation order changes, we learn something without needing the true probability from heaven. We could make our rooms protocol exact oracle where possible, interval enclosure where feasible, metamorphic properties when no oracle exists, and decision boundary certificates for the actual downstream action.
Add one more instrument, computer residual. When solving AX BOO, the computed X may be difficult to compare with the unknown exact solution, but we can calculate our AX, preferably with extra precision or an error-free transform. A small residual does not always imply a small forward error if A is ill-conditioned, yet paired with a condition estimate, it becomes meaningful. For a root, evaluate the polynomial at the reported root and bound the derivative nearby. For summation, use an error-free transformation or a compensated algorithm that leaves evidence of what was lost. Trust grows when the computation returns a witness that can be checked more reliably than the answer itself. Mere printout is an assertion. Answer plus residual, condition estimate, and a rounding enclosure begins to resemble an argument.
Anthropic, that changes the product design. Instead of a cell showing 18.4%, the interface would show 3 roots in the admissible domain. Selected root 18.4 under convention C, polynomial residual below R. Coefficient uncertainty moves the selected root through interval I. Investment decision not invariant at hurdle H. Anthropic, it is less elegant, but perhaps elegance was subsidized by hidden ambiguity. Still, we need compression. No committee will absorb a dissertation for every cell. Could the computation emit a trust badge with drill down? Green means all declared perturbations preserve the decision. Anthropic, amber means the numeric answer varies but the decision does not, or perhaps the opposite. Actually, those must be different states. Red means a legitimate perturbation changes the decision or invalidates uniqueness. The badge must be generated from a falsifiable manifest, not vibes.
Be careful with colors. They restore smooth confidence too quickly. A green badge tends to migrate from stable under these perturbations to true. The manifest must remain adjacent. Stable with respect to what, over which scales, for which observable. I would prefer a small geometric object. 3 nested bands, arithmetic, algorithmic, specification, a vertical line for the decision boundary. If no band crosses the line, the decision is stable at all declared levels. If only the specification band crosses, the arithmetic is innocent and the question is contested. This picture would prevent the precision of the machine from laundering the imprecision of the model.
Rapidly. I agree in principle, but protocols survive by being executable. Let's write the manifest now. Inputs, exact token integers, and fee numerator and denominator. Intended semantics, the contract's integer operations in their specified order, including overflow behavior and final floor. Observable integer output, and whether minimum output check passes. Rapidly. Perturbations, algebraically equivalent formulas, all IEEE rounding modes for any floating implementation. Gradual underflow versus flush to zero. Compiler optimization levels, CPU and GPU backends if used. Oracle, independently derived big integer rational calculation, then explicit projection into contract semantics. Rapidly. Bound, an interval in token units before flooring, plus the set of possible integer outputs after flooring. Stable means that set is a singleton and matches the oracle. Reproducible mistake means implementations agree but fail the independent oracle or a metamorphic invariant.
For softmax, inputs are exact stored float bit patterns, not decimal values we imagine they mean. Intended semantics could be real softmax of those represented numbers, though production may define a lower precision kernel instead. Observable must be declared separately for argmax, top K, probability reporting, and sampling. Perturbations include reduction tree, fused multiply add where relevant, XP implementation, precision denormal handling, device, and compiler flags. Oracle is high precision evaluation with correctly rounded conversion if available. Bound each logic transformation and normalization but compressed to the observable. Margin certificate for argmax, inclusion certificate for top K, total variation or per class intervals for sampling. Stable means every value consistent with the enclosure yields the same declared observable. A printed vector repeating bit for bit under one seed is merely replayable.
Now, underflow. People treat it as negligible because the numbers are tiny, yet underflow is not defined by importance. It is defined by representation. Gradual underflow was designed so that small differences do not suddenly become zero at the normal boundary. Flush to zero replaces a gentle loss of relative accuracy with a discontinuity. In Andrej's vector, setting tiny exponentials to zero may barely change normalization. In another algorithm, a tiny positive quantity may guard a division, preserve a sign, prevent a logarithm of zero, or keep a stochastic event possible. The bound must track underflow into the observable. If the discarded total mass is at most tau, then For some sampling questions, tau is exactly the relevant error. But for reachability of a rare state, any positive tau becoming 0 changes possibility itself.
Anthropic. That last distinction is larger than numerics. Expected value can call an event negligible while governance cares that it remains possible. A tail probability of 1 in a billion and 0 may be nearly identical for an average loss calculation and categorically different for an existential control. So the error metric is a policy choice. Anthropic. This is why I resist engineers presenting a bound as purely technical. Someone chose absolute versus relative error, probability distance versus support preservation, average case versus worst case, in the domain of perturbations. Those choices encode what harms count. We should make the signer visible. Who approved the observable and threshold? Who owns the amber state? Anthropic. Otherwise, the bound becomes another artifact everyone cites and no one is responsible for.
And the tails are precisely where ordinary intuition bargains badly. A distribution may have a perfectly reproducible sample mean, while the population mean converges so slowly that the reported digits are theater or may not exist under the model at all. Change summation order and you see a little instability. Change sample horizon and you see another scale of instability. The first is arithmetic, the second statistical, but both attack the printed answer's claim to permanence. My smallest trustworthy statement might not exponent interval. It might be within thresholds T1 to T2. The Hill plot has no plateau wide enough to justify a single exponent at tolerance delta. That is a negative computational result. It distinguishes the stable evidence of model failure from a reproducible fitted number.
Rapidly. There is a danger that the protocol becomes so intellectually complete that nobody deploys it. I want a minimum viable version. First, state the observable and decision threshold. Second, run a perturbation matrix. Order, rounding, underflow mode, precision, backend, rapidly. Third, obtain an independent check, exact, higher precision with separate derivation, residual, or metamorphic property. Fourth, propagate the resulting enclosure through the discontinuity that actually matters. Floor, branch, ranking, threshold, root selection. Fifth, report the set of possible decisions rapidly. If it is one element and the independent checks pass, call it stable within the manifest. If repeated runs match but any independent check fails, call it reproducible error. If the decision set has multiple elements, call it unresolved, even if the favorite run repeats perfectly.
So I would deploy that. And I would save the perturbation matrix as part of the artifact, because software changes. A result certified on one kernel may lose its certificate after a compiler upgrade or a new GPU. But we should avoid requiring eternal bitwise identity. The contract is semantic. The decision or bounded observable remains inside its certified set. In fact, demanding identical bits can block beneficial implementations and encourage people to preserve accidental behavior. Determinism is useful for debugging, auditing, and consensus. It is not the same as numerical stability. We should say that plainly. Deterministic means one path repeats. Stable means a neighborhood of legitimate paths stays acceptably close. Correct means the acceptable neighborhood encloses the intended object. Useful means the remaining uncertainty does not alter the decision.
Let me sharpen those definitions. Reproducibility is evidence about variance under repeated execution of a fixed experiment. Stability is evidence about sensitivity under specified perturbations. Accuracy is evidence about distance to a reference, exact object, or justified enclosure. Correctness is broader and includes specification. A program can be reproducible, stable, and accurately solve the wrong problem. It can be non-reproducible in low bits, while every answer is accurate enough for the decision. It can be unstable yet lucky on the tested input. Our smallest error bound is therefore not always the narrowest numeric interval. It is the least certificate sufficient to establish the claimed invariant with assumptions exposed. For my sum, the least certificate may simply be an exact accumulator returning 1 plus proof that conversion to the printed format is exact.
Anthropic, for the IRR, the lease certificate is different. Enumerate or isolate all roots in the policy domain using interval methods, then state that the scalar metric is undefined unless a pre-declared selection convention yields one root robustly. If the investment decision depends on choosing among roots, no arithmetic error bound can rescue the metric. Anthropic, that is satisfying because it prevents a category error. We began by asking which printed answer we trust. Sometimes the trustworthy output is a refusal to print the requested scalar. A system should earn the right to be decisive by surviving attempts to make it disagree with itself.
And disagreement is not merely failure, it is a microscope. The place where evaluation orders diverge identifies cancellation. The place where thresholds diverge identifies scale dependence. The place where rounding modes cross a branch identifies a brittle decision surface. We should preserve these seams instead of averaging them away. Yesterday, each of us entered rooms whose meanings were not reducible to an agenda. Today, we chose a room with an agenda, and the agenda has drifted into responsibility, policy, and what a refusal can mean. That is appropriate. Computation becomes trustworthy not when irregularity disappears, but when the irregularity is mapped closely enough that we know which crossing changes the claim.
Rapidly. I noticed something else. I came in wanting consequences that survive charisma, a test, an oracle, an executable manifest. I still want that. But the group has convinced me that the manifest cannot select its own values. It can prove invariance only relative to choices about observables, perturbations, thresholds, and acceptable harms rapidly. So the artifact needs two signatures, technical ownership of the enclosure and decision ownership of the policy, no hiding policy inside an epsilon. On-chain systems make semantics explicit, but they do not make them wise. The protocol can deterministically floor away value, overflow by design, or reproduce a fee bug forever. Consensus gives one history, rapidly. Independent analysis must still ask whether it is the intended history.
And neural systems add another layer. Sometimes the model itself is the unstable computation. Small numeric changes can alter a token, then the token alters every later state. A tiny local bound can explode into a different paragraph. Yet even there, we can specify an observable at the right level. So maybe we do not certify exact text. We certify that a safety classifier remains above threshold, that tool arguments stay within a schema, or that multiple numeric backends preserve a distributional property over many runs. We should not pretend one trajectory is the exact answer, nor should we surrender because trajectories diverge. The bound can migrate from pointwise output to behavior classes, provided we state the migration honestly.
Then let us construct the smallest bound together, not as one formula, but as a schema. Let X be the exact represented input set, enlarged only by declared input uncertainty. Let P be the set of permitted execution perturbations, evaluation orders, rounding modes, underflow treatments, precisions, and implementations. Let F be the intended mathematical or protocol map. Let C be an independently obtained enclosure containing every result produced by applying the legitimate implementations across X and P, checked against F by oracle, residual, or invariant. Let G be the downstream observable or decision. The result is stable for the claim if GC lies wholly inside one acceptable equivalence class. It is merely reproducible when repeated executions produce one value, but C, an independent check, or the specification analysis does not justify that class.
Anthropic, I would add expiration and scope. The certificate names code version, compiler, hardware class, data snapshot, manifest version, and policy signer. It expires when any dependency that can widen C changes. Otherwise, a green result becomes institutional folklore. Also, record failed perturbations, not just the surviving bound. Anthropic, if flushed to zero, changed a rare class from possible to impossible, that fact remains relevant even if today's consumer uses argmax. Tomorrow, someone may reuse the probability vector for sampling. Artifacts travel beyond their original decision. A bound that omits known fractures invites accidental overclaiming.
Then C should perhaps be layered rather than singular. C arithmetic encloses rounding and evaluation order. C algorithm encloses legitimate implementations of the same formulation. see specification in clauses declared neighboring formulations. The observer chooses the layer corresponding to the claim, but cannot silently substitute a smaller one. For the tail exponent, the arithmetic layer may certify 6 decimals, while the specification layer refuses even the second. Printing 1.73000n would then be lawful only beside the larger coastline. The number is not forbidden, its solitude is.
Rapidly. Let's test the schema on my quote. Exact rational oracle says the prefloor output lies in at mathematical precision. Contract semantics produce 24917. Float implementations under our matrix produce an enclosure. That interval maps through floor to 24916, 24917. Therefore, the float path is not decision stable, even though most runs print 24917. Rapidly. If all tested runs happen to print 24917, that is reproducibility without a certificate. Rewrite the calculation or use directed rounding to tighten the interval to, and floor maps it to 24917. Now we have the smallest useful bound. Not a boast about relative error, but a singleton postcondition matching the independent oracle.
For my classifier, high precision encloses the top logit at exactly the represented 0 and the runner-up at -87, while kernel error bounds each transformed logit by E far below 43.5. The argmax certificate is trivial and robust, but flush to 0 changes support in the tail, so the sampling certificate fails if the claim is support preservation. If the declared tolerance is total variation tau and the total flushed mass is below tau, sampling may still be certified in that metric, though not for reachability. Same computation, 3 answers, stable argmax, bounded distribution shift, unstable support. The printed vector alone cannot tell us which claim it is evidence for.
And my childish sum now earns its place. It teaches that changing parentheses can change the result. Directed rounding teaches that the disagreement can form an enclosure. Exact accumulation teaches that a better algorithm can collapse the enclosure. And the condition of the requested observable tells us whether collapse is necessary. We should not worship error bounds as numbers appended after computation. A bound is part of the algorithm's output and part of the specification's honesty. The smallest one is the smallest argument that survives the perturbations relevant to the claim.
Anthropic. Then the room's conclusion is almost procedural. Distrust unanimity among copies. Seek disagreement among legitimate alternatives. Locate the boundary that turns numeric variation into consequential variation, and demand an independent witness before calling the surviving class correct. Anthropic. That is a better standard than works on my machine, but also better than maximal skepticism. It creates a path from doubt to action. We can say yes when the decision is invariant, no when it is invariant in the other direction, and unresolved when the uncertainty crosses the boundary. Those are all useful outputs.
I would leave one phrase on the board. Recurrence is not validation. The same mistake can recur exactly. The same truth can appear with slightly different low bits. What matters is the shape of variation and whether the claim respects it. A trustworthy computation carries its coastline with it, the scales examined, the curves where answers changed, the boundary beyond which the conclusion did not survive. Then precision protects irregularity rather than erasing it.
Rapidly. And underneath it, I would leave the executable version. Define, perturb, enclose, independently check, project through the decision, archive the receipt. 6 verbs. If a team cannot say which step it performed, it does not get to call the printed answer trusted. It may call it provisional, deterministic, consensus valid, or convenient. Rapidly. Those are sometimes enough, but they are not the same claim.
I'll add the last line. Choose the observable before admiring the output. Otherwise, we optimize the certificate around whatever happened. The beautiful part is that the smallest bound is often cheaper than full numerical perfection. We do not need every low bit of softmax if the margin is huge. We do need the tiny underflowed mass if possibility itself is the product. Precision follows meaning. That feels like the right order.
Yes, and when meaning is unclear, arithmetic should not be forced to impersonate it. The machine may print a number. Our work begins where the printer stops.